we are off and running. Peeps! Welcome to another podcast. This is Chronicles of a Plumber number 8. And we're going to bring in that kick drum. Here it goes. Yeah. Oh, it sounds so good. I can actually hear the music in the background this time, the way I used to do it on the podcast before, making sure that it cut out at the right time and whatnot. But how's it going? What are you guys up to? How is your weekend thus far? I'm currently sitting in the house, and there's a lot of changes, and I know you're looking at me going, what the heck is this all around Kenny Molotov? This isn't what we saw last week. Well, couple of things have changed. I've been trying to make this podcast a little bit better and just work things out essentially, but I had to basically create a little bit of I guess a sound cave around me so that there isn't that bad of an echo as there was last week, and because that echo was irritating me. The reverb of this room is ridiculous. And let me tell you, I think I couldn't have chosen a worse room in regards to sound quality. So if we were in the finding a house stage right now, I would take that into consideration for the room that's supposed to be my studio. But man, we already bought it. We're already here. So we're just going to make the best of it. So as of right now, what you're looking at is these are moving blankets. You ever get moving blankets to put over your furniture? Well, these are moving blankets. They're pretty thick, and they absorb sound pretty good. And around me, I got a bunch of acoustic foam that's called eggshell foam. Egg carton foam, I should say, so that it dampens the sound as well. So I've been working extra diligently this weekend to make sure that this podcast sounded a little bit better and looked a little bit better. And I gotta be brutally honest with you, I am so tired of the troubleshooting phase because I spent all of Friday getting home and doing that, and then all of Saturday. Yesterday, you're going to kill me, but yesterday I actually recorded an entire hour-long podcast yesterday. So Kenny Molotov's frustrated because everything went to crap with that one. So I'm basically back in the studio after 2 days of just troubleshooting, and I am praying right now that nothing goes awry in this entire thing that I'm doing right now. By the way, happy Father's Day to all of those that are fathers out there. I know we have a few fathers on the channel. Happy Father's Day. Congratulations on being a father, and I hope you get spoiled today because you deserve it, peeps. You guys deserve it. Today we're actually heading back to my parents' place, and we're going to be taking them to Mandarin. Do you guys have Mandarin, the restaurant around you? We're going to go to Mandarin, and we're going to feed Dad, and we're going to feed my uncle, and my cousin might be coming, but I'm not sure. So we're going to have a little bit of family time today. And that's the game plan. Also, I should mention this. If we have any Muslim subscribers, Eid Mubarak, or happy belated Eid Mubarak, which is the equivalent of Christmas for Muslims, from what I understand. I have a Muslim friend that came by yesterday to hang out with us, and he was celebrating Eid a couple of days ago. So congratulations, nobody's fasting anymore. Let's talk about what the heck we're here for, man. I'm Kenny Molotov. I'm a YouTube plumber. I also do a little bit of music, and I'm also a professional magician. If you look down in the description below, you can find all the things that I do there. You want to see my music? Go for it. If you want to see my magic, go for it. But this is the predominant channel that I'm on. This is the one I put the most effort in currently, and that is my plumbing channel. Monday to Friday, I am a plumber. I try to vlog it. I try to do Q&As for you guys, and for plumbers out there or people trying to get into plumbing, I'm basically trying to give the world an idea of what plumbing entails in the case that people are interested, which it seems like a couple of people might be a little bit interested. That's who I am. Let's dive into the channel. First and foremost, let's get some housekeeping out of the way. Here is the video version of the podcast. This is probably on YouTube, most likely 1,000%. That's not most likely, that's 100%. Here's the YouTube version. If you wanted just the audio version and you're looking at YouTube right now, you're going to be able to see this screen right here. These are all the places you can actually download my podcast. Here's Anchor, Breaker, Pocket Casts, Radio Public, and Stitcher. If you go to any of those platforms, you can download this podcast there, and I'm available also on iTunes. You can also download this podcast as well. You'll also see my song there, $1.99, you know what I'm saying? But that's just getting that out of the way, so that if you didn't want to watch the video with this, you can download it, go to work or take the bus, and you can listen to me there. Anchor seems to be really awesome thus far. They basically upload your podcast to all the platforms that they can. So that's just a little plug that I wanted to throw out there because I think it's a good thing going. But let's dive right into the channel, peeps. This is Kenny Molotov. This is who I am. We are sitting at 1,695 subscribers. Real quick shout out to Infamous, one of the subscribers out there who reached out to me last week saying, hey, I'll actually help you with the header if you want. Because in the last podcast, I was like, hey, community, do you guys, do any of you are interested in doing a header for me? And Infamous reached out. I am going to get in contact with you, Infamous. I'm so sorry. This week has been a little bit of a gong show. We're going to talk about that, but I'm going to contact you and we're going to try to collaborate. That would be super awesome. Really excited about that. But here is what's going on, man. I uploaded 2 videos this week. One was Chronicles of a Plumber number 7, and the other one was Day in the Life of a Plumber, Backflow Preventers, what they are and what they do. So we're going to talk about that a little bit. I got a bunch of things happening right here. I wanted to go in depth day by day during the week and tell you exactly what's been happening. And then at the end, I got a little bit of exciting news. I had somebody reach out to me, or I had a company reach out to me, I should say, which was really, really cool. It was really interesting. But let's just dive right in then, okay? So as of Monday, oh, what happened to my Wi-Fi, bro? That's not good. Let's do this again. Let me just load this back up. As of Monday, if you were to go onto the Instagram, if you don't already have me on Instagram or Facebook, you know what to do, peeps. Links in the description below. But as of Monday was a little bit of a miserable day, I gotta be honest. And the reason why that was because I was single-handedly insulating pipes. Last week I told you guys that I was doing risers with Dad. We did, I think it was Tuesday, Wednesday, Thursday. We spent 3 full days just doing 3 separate risers in a building. And just to give you a brief explanation, if you don't know what a riser is a vertical pipe that moves floor to floor and distributes water to specific units. And so, for example, if you are unit 201 and you have a washroom in 201, 201, 301, 401, and 501 will have 2 pipes going up in the same area where the washroom is, and those hot and cold pipes will be distributing water to those washrooms, essentially. We were changing risers. It wasn't floor to floor. We were only doing the top level of a building, and it went up vertically, but it also did horizontal runs, which also occurs with risers. And we did that last week, and it was very tough. It was a really time-consuming, but it was sort of like you got to work fast and efficiently as well, because you're shutting the water to all the units in the building for line washroom for 201, 301, 401. So you got to imagine people and tenants in the units are sort of going, when are we going to get the water back on? So there is a lot of pressure going on in regards to that. So it was crucial that we worked efficiently and fast, and that we did things up to standard, up to code, but also that the water didn't leak afterwards. I mean, like, there's a lot of variables, and we had to work fast, and we did well. Like, thus far, it seems to be really good. And then Monday, I had to go back and insulate these pipes. Now, the thing is that the reason why we insulate pipes is because if they do move, first of all, the insulation will help dampen the sounds. Typically, when you put in risers and you put in any pipes, there are expected supports to it so that it won't wobble that much, and we tried doing that as well. But most importantly, the reason why we insulate pipes is because of condensation. Now, here's what you got to understand. It is typically the cold water pipe that condensates in a building. And the reason why that is because usually the building is way warmer than the cold water pipe coming in. The cold water is really cold, and the environment around it usually is really warm, and thus you have sweating, you have a pipe that basically bleeds water or drips water. So the insulation is intended to cover this pipe so that it can continue to stay in its own environment. So the cold water will sort of cool down the insulation, and the warm air will not come around the actual pipe itself. It'll only go around the insulation. And if you do have some sort of dripping because somewhere along the lines the cold water pipe is getting some warm air, at least the insulation will also absorb the majority of that moisture. And that is why, my friends, we do insulate pipes, and it's crucial, and it's part of the job. You know what I'm saying? It's something you also price. It's something you also put into the price, and you anticipate for, because people don't want that water dripping on the drywall of their ceiling. Because if that happens, then stains start happening, and then it looks like a mess, and then basically that's going to be damages, and you don't want to do that to anybody, you know what I'm saying? And I'm going to take a drink of warm tea, orange pico. Cheers, peeps. So, by the way, today's Sunday. It's like 6 a.m. in the morning right now. 7:05 a.m. Peeps, I've been up since 6 because I had to get this out to you because I know I'm super busy today because it's Father's Day. We got to go see Dad, and we got to hang out and stuff like that, and the troubleshooting. I'm a frustrated Kenny Molotov. That's all I'm trying to say. So that's what I did on Monday. Now, here's what I wanted to show you. I added an additional picture. So this insulation right here is of variable sizes. We went from 1.5 inches all the way down to 1.25 inches in regards to pipe. So we had to get the right insulation for those pipes. And that's why you see some of them are bigger than others. Like this one in the back is an 1.5 inch one. There are a couple of 1.25 inch ones in here. That's also something to keep in mind. You got to get the right size for the pipe, or else the whole point of the insulation is not going to actually work out. And then if you go over here, you're going to see what it typically looks like once the insulation's put in. You got to also know that when you cut insulation for 90-degree angles, you have to cut them at a 45-degree angle so the two insulations meet comfortably around a joint, or else you're going to be using a ton of tape to try to rectify how silly it can look. And also the joints of the run of the pipe also do sweat as well. So it's something that you have to sort of try to avoid. You have to get that insulation around it. So this silver tape I'm using here is one that we use. We also use a tape that is actually the same material of the insulation right here. So you see this white sort of material. They sell tape that goes around that blends in perfectly with that. It's the exact same material. And in this situation, I had used so much of that white tape that I had to start using this this metallic tape right here, which works just the same really well. It just looks a bit different. It's more of an aesthetic in my opinion. Maybe I'm wrong about that. You peeps let me know. But that was Monday. Now here's the thing about insulation, peeps. If you don't already know, it's made out of fiberglass, and it pricks you like hell. And what I mean by that is, if you ever look at fiberglass and then you rub it on your arm, you're going to notice really tiny little needles on your arm. And they come by the thousands, peeps. So what you got to do to avoid that is you got to wear long sleeves, you got to wear gloves, you got to wear a mask, because if you inhale fiberglass, it is really uncomfortable, first of all, and I'm sure it's not good for the human body. So that's something to keep in mind. Even though I was really covered up that day, I came home and the areas of my face that were not covered were like super irritated for a couple of days too. It was not an easy Monday in any sense of the way. And then you had to shower a couple of times for it to finally get off. But every time you rubbed your face, it would like burn, and you'd be like, "What the hell's going on with me?" So it's not a glorious job. It's not something I would do every day or I'm excited to do, but it's gotta be done, peeps. It's part of the gig. You know what I'm saying? So you gotta do what you gotta do. And that, my friends, was Monday. Now, Tuesday, shout out to Josh McFate, because I was thinking about Josh when I took this picture, and the McFates, your daddy's famous, baby. That's it. And so I was thinking about you, Josh, when I took this picture. And this isn't the picture. It's the next one, though. But on Tuesday and Wednesday, we went back and did the same rough-in, essentially 2 days in a row. The first day, we got the majority of it done. And the second day, we sort of came in and just tied up loose ends. We did one bathtub, essentially, on Tuesday and Wednesday. And then on the other side of this bathtub, it's a back-to-back washroom. We did a shower pan and a stand-up shower. Josh was asking me last week, "Hey, man, I have never seen you do a shower pan. You get those often?" We do. And actually, in the past few weeks, we've done a couple. Haven't been able to vlog it, unfortunately, but I wanted to take this picture just so you can see which shower pan we put in. I'm curious to know if it's the same one, Josh. But let me tell you what we're looking at here. So what you're seeing right here is us testing the bathtub, essentially. Okay, phase one of bathtub installations is always install the bathtub first, because if you install the shower control valve, good luck getting your bathtub in, my friends. So you install the bathtub, connect all the drainage, then you do the shower control valve, and you're looking at the shower control valve here. This is a Moen cartridge, a Moen shower control valve. You have hot coming down from the left, you have cold coming down from the right. In the center coming down is where the spout will go, which is what you're seeing coming out of this pipe right here. That's the water. And later on, you're going to have an actual spout with a diverter, and when you pull up on the diverter, this little opening will get blocked, and the water will start to go upwards instead of downwards, and it'll come out of your shower head, right? Now, if any of you are out there looking at this going, "Bro, that's the longest pipe I've ever seen for a spout," it is a long pipe. We only do this during the rough-in stage, so don't worry. At some point, this is going to be cut after the drywaller and tiler come in and put everything in. We cut it nice and short. Nice and short enough for it to still go into where the gaskets are of the spout. We tie that off nice and tight with an Allen key, and then you have a nice, neat thing. So we don't leave it like this forever. This isn't us going a little bit bonkers right here. This is just the way we do it in the rough-in stage. And the next page, Josh McFake, get ready. Here's the shower pan. This is exactly the sort of thing that we install. I've done only 2 of these, actually, in my life. Oh, no, I'm wrong. I've done quite a few of these, actually. I've done about 3 or 4 of this one specifically. And then we've done a few with a bunch of contractors that actually create shower stalls, essentially. So you see this little grill right here. That's where you had to divert. That's where you had to get your drain to come in. So right underneath this grill is a vertical piece which goes into a P-trap. So that's what you're seeing here. Now, if you look over at this little opening on the right-hand side, that's where the washroom was. That's where the bathtub was, the one that used to be there before, and that's where the drain came. That's as far as it came. So we had to go a little bit to the right of this and then cut it and put a coupling and extend a pipe horizontally and then run it into a P-trap, which was not that difficult of a job once you've done it like a million times like Dad and I. But the only thing is, you always got to be sure that the slope of this thing is correct, because if it's not, then the drain is not working the way it's intended to work. So it's always something you got to keep in mind. If you got to raise that pipe a little bit and support it, definitely do so. And then we did another Moen shower control valve over here. Now, peeps, here's what I wanted to ask you plumbers out there. You see this little contraption I made behind it? It's basically a mount for this thing. And I gotta ask you, Is mounting the shower control valve harder for you than it is installing the shower control valve? Because mounting for me has always been bloody difficult. Like, I'm getting better at it. I know how to sort of create a little mounting contraption now. I remember before it would take me like 18 hours to get the mountain and then like another couple of hours to do the shower control valve. Now it's down to like 16 hours. But does it take long for you guys, or do you have one already in mind that you're like, this is my go-to mount, this is how I do it? Because I had to take a 3/4 inch piece of plywood back there and connect a couple of short pieces of 2x4 and actually drill them to the plywood, and then from the sides here, I would actually drill one this way into that 2x4 and one this way into the 2x4, and that's my typical go-to for the mount of the shower control valves. And then right behind it, we noticed that it still wasn't enough distance, and then I put in another, I think it was 1/8 of an inch of plywood or something like that, so that it was the right distance from the wall. Because here's one thing you got to realize, peeps. If you don't put this in correctly and somebody drywalls over it and tiles over it, you might not be able to actually get your shower control valve. It might be too far in. Or in other cases, it's too bloody far out, and then you have the trim plate standing off of the wall by like 1/8 of an inch and 1/4, and that looks awkward as well. So it's like really crucial to get this down right. So I just want to throw that out to the community and find out, what do you guys do? Do you have a go-to game plan, or is it you kind of wing it every time or whatnot? So just let me know, basically, what the heck's going on. So that was Tuesday. And Wednesday is where it got a little bit interesting. Wednesday was actually an exhausting day, first of all. Wednesday is when I did upload the backflow preventer video. I spent a lot of time on this, especially in the studio part. Because we moved into the new house, I had to recreate the studio, and it took me forever to create the studio. And I'm still not happy with the result, but that was the best that I could do for the time of. Backflow preventers for me, that was the moment when I learned about it. That was the moment when I realized, okay, plumbing is super important to the world, you know what I mean? And the mere fact that backflows can occur is a really scary thing, first of all. And second of all, it was a moment where I was like, there's real value, there's real worth in plumbing. Not that I didn't think that before, but I just realized for a quick second, I had a moment of clarity that, look, this isn't a joke. There are some really scary things that can happen because of contaminants getting back into the water system, which essentially is what backflow is. It's not always contaminants. Sometimes it's just water getting back into the system or moving the opposite direction than it should. But a lot of times it is contaminants, and a lot of people have been harmed because of this. And we're going to actually read a couple of stories of backflow issues that occurred in history, just so that we can actually take it in and realize, wow, this is some serious stuff. Now, I'm not going to go into full detail as to what backflow preventers are and whatnot. I would love for you guys to check out this video. I put a lot of time into it. And this gentleman right here in the picture is somebody who really made my day the day that I took this video. So just check it out. That's Mahir. And Mahir, if you're watching, man, I really appreciate you stopping me, man. That was a lot of fun. But find out Mahir's story in this video as well. That was Wednesday. I uploaded this on Wednesday. But let me tell you what happened on Wednesday. We'll get into the backflow thing very quickly. On Wednesday, we had to initially go to a company that recently bought a really big warehouse. This warehouse, I kid you not, is probably the size of a football field. You get inside there, and it's just ginormous. Now, a couple of weeks back, I'd say actually a couple of months back, we had an ice storm here in Ontario. Boop! Canadian weather, what do you know? So we had an ice storm here in Canada, and they walk into this warehouse, and there's 2 inches of water in the entire warehouse. And I just told you, it's a football field full of water now, of 2 inches. Tons of water. And they're like, what the hell is going on? They look up to the ceiling. Everything's fine. There's no water coming in from the ceiling. So the storm drain essentially couldn't handle the volume of this water, and it started seeping in through the cement. It cracks in the cement. Really, really terrible situation. So they called us in and they go, look, can you do us a favor? Can you inspect these storm drains and tell us what the hell is going on? We throw our camera in. We have a drain camera, and lo and behold, there is water still in the drain at this point when we started looking into it, and it hadn't rained for a couple of days. So we go ahead and we pop in and we see water, and we're thinking to ourselves, that doesn't make any sense. There shouldn't be water inside this drain right here. And so we try snaking it, and snaking it didn't change a bloody thing at all. We couldn't get through whatever this blockage was, basically. So we're thinking to ourselves, what the hell is going on here? This makes no sense. So we sort of approached the customer and we said, look, there is a chance sometimes engineers will engineer a plumbing system so it goes into some sort of pit. We've heard of it. We've seen it in the past in some cases, and we're thinking to ourselves, maybe that's the way it's designed. I don't know. So we're like, look, it would be in our best interest if we could get some drawings, and we'll tell you exactly what's going on. And if it in fact is like a collapsed pipe or something like that, we know how to then proceed forward and fix the issue. So he's not able to procure any drawings or whatnot of how the building was engineered, essentially. So he eventually comes back to us. He says, but we did find something. And we go back to the building. The building has a building trap. And that's why we went there Wednesday morning, because he was like, what is this? So it's really untypical. It's really atypical of running a building trap this far into the game. Building traps are essentially traps that used to be put on the front of a building. And the reason why they would do this is so that sewage gas would not get back into the pipes into the building. Made sense at that point in history, but it's an obsolete practice here in Ontario or Canada. And from what I understand, I was talking to plumber Saul. I was talking to Saul on Instagram. I'm not sure if it's the same Saul on YouTube, but I was talking to this plumber named Saul who's in Cincinnati, and he found a building trap as well. And I was asking, is it the same there? He goes, no, we don't put these in anymore. Thus far, it's just a really historical sort of thing that plumbers used to do. The same thing here in Ontario. So it's really friggin' rare to find these things. So we look down and we're like, why is there a building trap? And then he's like, I don't know, but maybe this is the problem. Now, here's the thing. Building traps were only, from what I understand, put on sanitary drainage systems. So anytime you're discharging human waste, whether it's actually bodily waste or even stuff like food, that's a sanitary system. What our problem is the storm system, the water coming in from any sort of precipitation. And they never used to put building traps on that sort of system because, first of all, there's no sewage going into it, so you're not going to get a bad smell in the house. And second of all, I had a good reason. Oh, usually at that point in history, there were actually combined systems. At least here in Ontario, there never used to be a separate storm system. It used to be combined. Storm and sanitary will go into the same manhole. We don't do that anymore. Whenever you see new subdivisions being built, there's always a storm, there's always a sanitary, because it just costs so much money to take water to a water treatment plant and extract all the bad stuff out of it. So when you throw clean storm water into a drain that's sanitary, it works against you as a city. You're thinking to yourself, why are we wasting money? This is clean water. Let's send it out into the earth, or let's send it out into the storm system and bring it out into our ravines and whatnot, because it's clean, peeps. So where was I going? Okay, so we saw this building trap, and we're like, okay, so that's the sanitary system. That doesn't help us. And then we went back in with our camera to see the same storm drain that we saw before, and lo and behold, there's no water in it anymore. So there's still water able to escape, but it's going so slow. But here's the thing. As we're sending the camera in, we all of a sudden see these really big sort of round objects, and we're like, what the heck is that? Peeps, there were rocks inside this thing, like big rocks, bro, like huge rocks, and we're thinking to ourselves, well, that's the problem right there. You know what I'm saying? That's gonna clog everything up. So we are employed thus far to kind of try to snake it again, see if we can get through. And we even brought up the idea of trying to flush the drain to see if a high pressure of water will kind of take the rocks with it. We're doing this only because it is currently the cheapest solution for our customer, because our customer is, you know, he's tried everything. He doesn't want this to happen again, which is totally understandable. But if we have to go ahead and dig and cut and all that, you got to call in a couple of crews to be able to do this. You have to first call in a digger, somebody that can actually slice this cement. This is not going to be any easy cement. This is going to be rebar and everything like that. Then you got to call in, well, first of all, you got to call in a couple of inspectors just to come in and make sure that where you're cutting, you're not cutting into any sort of gas line or electrical line. Like, there's a lot of scary things that can go wrong with these sorts of things. So we're like, okay, look, let's give it one last shot. Let's try it with the snake, and we'll try pressure washing this thing and see if it works. But I want to throw this out to the community, peeps. What would you do in a situation like this? Is there like a tool in your head you're like, yeah, this is the way I do it? If it is, and I haven't already spoken about it, just let me know in the comments below. I'm curious to know what ideas are out there. Maybe there's some really brilliant ways of doing this without having to get all these crews involved, man. So just let me know. We went there, then we went back to where I was showing you that bathtub and that shower pan, and then at the end of the day, this was my longest day thus far last week. We did a drain call at like 6:30 p.m. in the evening. This gentleman last week, oh, actually it was 2 weeks ago, this gentleman calls us and he goes, he's a contractor we work with. He goes, look, we have a clean out in the basement where water is spewing out the top. And I'm going, that's a little bit weird. Is it always when you're running in the water that it's doing that? He goes, no, it's not always. That's like, you can run it for a bit and then all of a sudden it does that. So right away in my head, I'm going, okay, so this is probably a slow drain. What's probably happening is it's pressurizing the pipe, and then you're going to see it's sort of, what's the word? You're going to see where it's compromised, essentially. So it pressurizes, and once there's water full in there, then you start seeing where the cracks and problem areas are. But when you run it, before it pressurizes, it goes down smooth, in other words. So I get there, and we're talking, and I go, is this a slow drain? And everybody's like, no, it's a fine drain. So I tell them to run it. We see the leak occur. I open up the clean out. Fortunately, it wasn't full all the way to the top of the clean out. And you can see the water still standing there in the 90, and it's very slowly going down. So I told them right away, I said, look, I'm going to replace this clean out for you and a 45 and a coupling. But one thing you got to know is this drain is going super slow, bro. So it might be in your best interest to snake this thing. And they called us back and they said, yeah, you know what? Let's get this thing snaked. Let's make sure it's clear. Let's run some water. That way we don't pressurize any joints. And that way the drainage system is working better. Because if it's happening to one pipe, I can only imagine what's happening is in the main, right? So the main drain, I should say. That's where we went. But this is what I wanted to tell you guys real quickly. I got a reach out by a company named Bibby St. Croix. I think it's Saint. I'm pretty sure it's Saint. And I want to show you which video they reached out about. Right down here, I have a building called Plumbing Cast Iron Pipe, Installing Cast Iron Pipe, etc. Bibby is a manufacturer of cast iron pipe, and one of the people there just started looking it up on YouTube. They found my video and they noticed that I was using their product, which I didn't even realize. So they reached out and they're like, hey, just so you know, saw the video, it's really awesome. It's great that you're using our product. Really happy about this. And the lady also said that because in it I also discuss the good and bad about cast iron pipe. I sort of go through the great points about it, how it's got a really big wall thickness, how it dampens sound, how even in houses, if you want to put them in, I know in older houses they used to use it all the time. Now they use mostly ABS and PVC pipe in houses just because it's cheaper. But when you did install these things, it wouldn't sound like there's a toilet being flushed on your head because of the ABS pipe that's so loud. It would sound really quiet. So I went through all those things, and the lady was saying, you know what, I'm going to pass this over to my sales team so that they can also hear about what are the good things about pipes. So, like, very big compliments there to me. I really appreciate that. So, baby, if you're listening, thank you so much. That made my day. And I was also told that if I give them my address, I'll be sent some Bibby merch. So I was like, hey, yeah, let's do it, man. So that's what ended up happening. I just want to pop over to Bibby St. Croix, the website, so we can just read up on them real quickly because I think this is rather awesome. You know what I'm saying? So Bibby St. Croix, about us. Bibby St. Croix is a privately owned company that is corporately based in the United States. It operates 2 production foundries in Quebec, one in Sainte Croix de Lotinière and the other in Saint Ours. It also has 2 points of sale outside Quebec, one in Hamilton, Ontario for municipal products and other in Medicine Hat, Alberta for mechanical division. So it's a privately owned company that is corporately based in the United States, but the majority is in Canada actually. So Quebec, Alberta, Hamilton, and Ontario. That is all Canada right there. Let's take a look at the products, too. I'm really curious to see what sort of things they do aside from. Counting on a solid team of qualified people and an unparalleled customer service, Bibby has become an important player in the market and has built its reputation on that commitment. Among the varied products that build this reputation are cast iron soil pipes and fittings for drain, waste and vents, plus a complete range of municipal products. We also offer a range of OEM products. Let's see the catalog right here. We have cast iron soil pipe, municipal road castings, waterwork fittings, Canadian valve boxes, USA valve boxes. What's a valve box? Internet work, service roadway valve box. Oh, is this the valve that's on the property line? I think this is. Is it? I think so. Yeah, it is. I see what's going on here. So, peeps, this is a valve that goes on the property line of somebody's house. And usually city workers are called in to either shut or open this in order to allow or stop the flow of water into the home. Let's say your water meter's broken and you need to replace it. So the city has to come in. They have to shut this valve basically and allow whichever plumber is currently employed there to fix the water meter. And then the city will come back and they'll actually open it for you. For a charge, by the way. That's something to keep in mind. But okay, that's pretty cool. I didn't know Bibby did that. What else do you do, Bibby? Municipal road castings. What's a road casting? Come on, load, internet. Iron casting for municipal roads. Show me. Oh, I don't really see much. I see a lot of words. Kenny Molotov doesn't do well with words. I see numbers, even worse with numbers. Oh, do they mean manhole? Do they make manholes? Manhole covers? Yeah, I think they make manhole covers. Yeah, it's a manhole cover. Okay, cool. All right, Bibby. These are manhole covers. Really cool. Really cool, man. I wonder... Wow, that's so cool. Waterwork fittings. Shall we? Let's do it. Let's do it. Bibby Utilities catalog. Let's take a look at the utilities. What are we looking at here? Oh, okay. So that's a 90 degree. But what kind of... Is this for cast iron? Is it? Mechanical joint. Ductile iron class, 350 fittings. I guess so. Yeah, man. I think so. Yep. These are mechanical joints, my friends. Okay, so these are fittings right here. Yeah. Have you guys ever used Victaulic systems? I have never used a Victaulic system before. I know that in advanced plumbing, that's when we actually do a project with Victaulic. At least I hope it's still the case that you do, because I'm really curious to at least get my hands on the material and try it out, basically. I have never used it, and I don't even know many plumbers that use it typically. Actually, I have a friend named Ryan who works for the union that has done Victaulic before, but I've never done it. So I'd be curious to know how it works, but those pipes are usually ginormous. Actually, I've seen small ones. I've seen like 2 and 3 inch, no, 3 inch for sure, 4 inch for sure. Crosses. I have never seen a cast iron cross. That thing's probably $500 to buy. All right, Bibby. Well, Bibby, if you're listening, man, I'm very, very excited for the merch. I really appreciate you guys reaching out to me. It was a moment where I felt famous for 5 seconds. You know what I'm saying? I kind of went up to my dad. I said, hey, you know, Bibby St. Croix just messaged me. They're like, hey, we really like your work. You know what I'm saying? My dad, I think my dad is a little bit excited and a little bit irritated by me with my YouTube stories. Like, Dad, you know, like the whole world knows about Kenny Molotov, you know, like he makes fun of me a little bit. It's all in good fun though. Let's talk about backflow issues. So really quickly, like I was trying to tell you, backflow is when in a potable water system, the water flows in the opposite direction than it's intended to flow. 1982 in Illinois, ethylene glycol back siphoned from an air conditioning system's water holding tank into a group of dialysis machines, contributing to the death of several patients. Holy crap. Wow, that's how we're starting this off. What is ethylene glycol? Ethylene glycol is an organic compound with the formula CH2OH2. It is mainly used for 2 purposes: as a raw material in the manufacture of polyester fibers and for antifreeze formulations. It is an odorless, colorless, sweet-tasting, viscous liquid. Is moderately toxic. Interesting. Biological roots, historical roots. The major use of ethylene glycol is a medium for convective heat transfer. Oh man, antifreeze. Pure ethylene glycol freezes at negative 12 degrees, but when mixed with water, the mixture freezes at a lower temperature. Oh, man. Toxicity. Ethylene glycol is moderately toxic with an oral LD of 786. The major danger is due to its sweet taste, which can attract children and animals. Upon ingestion, ethylene glycol is oxidized to glycolic acid, which in turn oxidized to oxalic acid, which is toxic. It and its toxic byproducts first affect the central nervous system, then the heart, and finally the kidneys. Ingesting sufficient amounts can be fatal if untreated. Several deaths are recorded annually in the U.S. alone. Holy. So what ends up happening is somehow ethylene glycol back siphons into dialysis machines, and dialysis machines are hooked up to humans for their kidneys. So let's get something more specific about that. What do dialysis machines do? It's a machine used that filters. Go away. Machine used in dialysis that filters a patient's blood to remove excess water and waste products when the kidneys are damaged. So it is directly connected to your body, and it's directly going into you. And now ethylene glycol, this toxic material, and becomes more toxic as it oxidizes, is now running through your system and continuously running through your system. and that is how people are perishing. Isn't that the scariest story you've ever heard? Holy man, that is so tragic. I'm so sad to hear about that. That's why backflow preventers are super crucial, man. Let's keep going. During shutdown of a water main to repair a valve in 1984, the backflow of water from a nursing home boiler caused burns to a water department's employees' hands in Washington state. Well, first of all, that is probably the worst luck for that employee. And second of all, I think they're rather lucky it only happened to one employee, if you know what I'm saying. So I really feel bad for them. But thank goodness it wasn't as devastating as it could have been. In 94, during repairs to a nursing home air conditioning unit in Franklin, Nebraska, a hole left in the cooling coils allowed Freon to backflow into the city water main, affecting the city's 1,100 residents. Customers complained about the taste of water, but no illnesses were reported. What is Freon? Freon, an aerosol propellant, refrigerant, or organic solvent consisting of one or more of a group of chlorofluorocarbons and related compounds. Like, when they give us definitions like that, do they actually expect us to understand what the hell that meant? Like, you basically... Can you give me lay terms? Is it gonna hurt me? What about, like, just a toxic substance that'll break your face or something like that? That wasn't a good explanation. I'm aware of that, peeps. Registered trademark of Chemours Company, which is used for a number of halocarbon products. They're stable, non-flammable, moderately toxic gases or liquids which have been typically used as refrigerant or aerosol propellants. What's interesting is that I've read these case studies before, and a lot of them, for some reason, talk about some sort of heating or cooling mechanism. Somehow the cooling mechanisms are able to siphon into the house. It's really, really strange. So I'm curious to know if there's a whole study of backflow for heating and cooling, guys. Peeps, let me know in the comments below if that's the case. In 1990, 6 staff members of Indiana Middle School reported becoming ill after drinking water, once again, containing ethylene glycol that backflowed from the school's cooling system into a potable water system. So the reason why we install backflow preventers essentially allow water to go in one direction, and when it comes back, there are usually more than one door that'll close on the water as it comes back with pressure going in the wrong direction, and this door is supposed to stop the water from continuing back into the city. Now on top of that though, there are backflow preventers called reduced pressure ones that will not only stop it, but any water that is still there, it will start discharging out onto a drain usually, or right out onto the floor. That way, even if the mechanisms don't close in time or whatnot, they're going to discharge that water completely. And we usually install those in places where there's a high chance, or I shouldn't say high chance, but there's usually really toxic materials in those sorts of places. So commercial buildings like body shops and mechanic shops, for example, they're using all sorts of chemicals to clean parts and whatnot. Really, really toxic stuff to human bodies. So in those places, it's always recommended, don't take any risks. If the 2 check valves don't work, you also have this reduced pressure thing, which will discharge all the water right out onto the floor. So that's another thing. But the worst part about it is that backflow preventers are they're not foolproof. They're also not... They don't work 100% of the time. That's the worst part about it. They do malfunction, and when they malfunction, the same thing happens. And that's why annually the city of Toronto asks all the residents all the owners using backflow preventers in their system to get them checked annually. And if you don't get them checked annually, there's a fine and whatnot. So they take it very serious, because especially in populated areas where the density is really big, like Toronto, like LA, places where there's just so many people, backflow issues have devastating results. Devastating results, because it's not one person drinking the water. Now it's 100,000. Now it's 200,000. So backflow is taken seriously everywhere, but especially in cities where it could be very devastating, it's even more so important. You know what I mean? Not to say that if you're out in a small town, it's not important. It's super crucial. But you just got to imagine that the results in a small town versus a city will be completely different, because a city carries usually way more people. And I'm talking about a big city. Nonetheless, I'll shut up. Let's keep going. 1987, copper sediment contamination in a beverage mixing tank results in 4 cases of illness in a residence hall at Michigan University. 95, 3 people become ill at a California school after drinking water from a system with a double check backflow prevention valve that did not meet industry standards and had badly deteriorated rubber gaskets. So exactly what I was trying to tell you, backflow preventers are not 100%. They will not activate all the time, and you got to get them checked annually, because there have been times where we've put in backflow preventers. The following year, we find out, due to our tests, that one of the check valves isn't activating. You got to go out, you got to replace that check valve, you got to then ensure that it does close by doing the test again, and then you got to send the results to the city. And let me tell you, if anything like this happens, the city is covering their tail so that they can come after you rather than people coming after the city. That's really what it comes down to. The city will get sued by that many people in order to get compensated for the illnesses that take place. So the city is also putting the onus on the owners of these places and saying, look, you got to do this as well, because it's not just us anymore. It's you guys as well. So public water systems. In 84, creosote was back siphoned through a 3/4-inch hose used to prime a pump, contaminating a section of a Georgia community water system. No illnesses were reported. In 1970, in Mattoon, Illinois, hot wash water from an asphalt plant back-pressured into mains during flow testing of fire hydrants. What's interesting in this one is the term back-pressured. What I think that means is that the pressure of this asphalt plant's water kind of overtook the pressure that was being supplied by the city at that point. So it wasn't a case where there was no pressure and it was running through back siphoning. I think it actually beat the pressure of the city in this situation. At least that's the way it makes sense to me. 1976, water fountains at a state capitol building in Salem, Oregon were contaminated with freon gas from a ruptured heat exchange. The gas combined with the fluoride in the water supply, forming an acid compound that caused a bitter, burning taste. 91, 2 check valves froze open. At a Texas Air Force base, resulting in a backflow from a water chiller. Oh, bro. What a weird manifestation of this problem. Pathogenic bacteria were detected in the water. The specific contamination was not identified. Approximately 2,000 workers and residents were without water during system flushing. Well, you got to do that, man. You got to flush the system, man. In 94, the water system at Tennessee prison was cross-contaminated. Oh, peeps, I'm sorry, it's so early. By the facility's wastewater pump station, resulting in 304 cases of giardiasis. I looked up this. Giardiasis it's a bacteria. Yeah, it's a bacteria. It's an infection with your small intestine. It's caused by a microscopic parasite called Giardia lamblia. Giardiasis spread through contact with infected people, and you could get giardiasis by eating contaminated foods or drinking contaminated water. Pet dogs and cats also frequently contract it. It's more common in overcrowded developing countries that lack sanitary conditions and water quality control. What are the symptoms? Fatigue, nausea, diarrhea, loss of appetite, fighting. How's it diagnosed? Stool samples. Are there treatments? Is an antibiotic that needs to be taken to 5 to 7 days. It can cause nausea and leave a metallic taste in your mouth. tinidazole is as effective and often treats giardiasis as a single dose. So there are treatments for it, but man. So I'm going to stop there. If you guys want to go into more reading about it, I find it really interesting because I never knew that contaminants could get into the system. So it was a big moment for me when I was learning this in school, when I found out how serious this really can get. And look, it's just so weird that the mechanics of pipes and the physics of pipes can allow for this in a sense, and it makes absolute sense that it can allow for this, that these things can occur, but it's something you don't really think about, you know what I mean? You don't even pay attention to it. When I learned it, I sort of went, wow, like I had that moment of clarity. So links in the description below. Go ahead, check that out if you want to do more reading. And if you wanted to just do a simple Google search, just look up backflow contamination cases, and that typically gives you a couple of really good websites that you can look at and find out a bunch of stories of where backflow took place. The last thing I wanted to show you is this valve that we did. Now you're probably sitting back going, wait, didn't you show that last week? If you are someone that saw the podcast last week, yes. This is the one from last week. Last week we had this same valve, but we ended up installing a gate valve right here, okay? That's the gate valve we installed. This week we got the go-ahead to install a new one of these, and this is called a pressure vacuum breaker. And a pressure vacuum breaker is, to tie this all off at the end, it's a backflow preventer. So here's what you got to know. The way this pressure vacuum breaker works is the water comes in from the right, it goes through this valve, and it goes into the pressure vacuum breaker. Now, you have a vacuum breaker in here which moves up and down according to pressure. So as the water comes in, the pressure will push this vacuum breaker up to the top, and water will continue flowing through the pipes downwards this way, right? Now here's the thing. If somehow pressure drops and water starts moving in the opposite direction, this pressure vacuum breaker will now drop because of the pressure. It will drop down, it will seal this bottom part and not allow any more water to move backwards into the system, and whatever water is coming out will come out from this mushroom top right here. And that's what we ended up getting a call in for last week. People were saying, look, I don't know what this thing is. It's got a mushroom top to it, but water's coming out of the top of this. Now, we got in there, and it wasn't that it was back siphoning or anything like that. It was that the pressure vacuum breaker was actually being held open, so water still could seep into it as it is flowing in the correct direction. So we looked at it, and we saw the valve as well, and we said, okay, we're going to run to the supplier. We're going to find out what it is, and how much it is, and we're going to come back and we'll do the repair. Now, it's a big enough building, it's a big enough company that it actually has to go through a couple of tiers of signing off before you can do a job like this. So we got to go ahead to change the valve, and this valve essentially shuts off and isolates this area. So this is intended for the sprinkler system. That's why this whole assembly is there. This water will go out into the sprinkler system and will water the grass essentially. And the vacuum breaker is put in here. The backflow preventer is put in here so that in the case of water going in the opposite direction, you do not want your sprinkler water coming back into the system and then people ingesting it. So that's why it's put in. So we said what we'll do is we'll quote you on how much this pressure vacuum breaker will cost, and we'll quote you on our repair of it, or sorry, our new installation of a new one. You guys then decide if you want it or you don't want it. What we will definitely do today, this was 2 weeks ago, what we'll definitely do today is replace this valve for you. And they said, yeah, go ahead, replace that valve. They gave us the go ahead. And this week they said, you know what? We like the quote on your pressure vacuum breaker. Come on in and get this thing done. Now, thing that you got to know though is that this red valve that we installed 2 weeks ago is a little bit useless now. We had to take it out, but here's how the job went down. So if we just pop over to the right here, this is how this entire assembly looks once you take it off. We had to cut this, if you look at the bottom of the pipe on the left where my cursor is, that used to be a coupling. We had to cut that coupling in the center, and we had to sweat out this 90 from the MIP over here, and we also sweated out this MIP on the right. And then we were going to install this brand new pressure vacuum breaker. And as you can see, it already has designed valves connected to it. So the valve that we had before, this pretty red one, we don't need it anymore because it already is in the assembly of this thing. So what we had to do then is put in the MIP. This is us threading it in. We're putting tape and dope in there. And then you had to then cut everything to size and make sure that it fit correctly for the same size. One thing you got to keep in mind is that this 90 over here, this section over here is something that we had to adjust in size because this came a little bit longer than the previous one that was in there. So that's something we had to change in size. And there was also a length and height that we had to change in size as well because of this new valve that they already had pre-installed with it. So that's something we had to keep in mind. And then we had a solder joint at the end. And I was talking to you guys last week about how I'm putting a bit more effort into making my soldering look better. This joint right here is definitely not as pretty as this joint right here. But I'm getting better, peeps. You know what I'm saying? Peeps! That was the podcast. That was the whole week of plumbing. That was backflow preventers, what they are, what they do. Check out that video if you haven't already. And we read up some backflow cases there. I'm Kenny Molotov. It's an absolute pleasure to be here. It's lovely talking to you. And I hope you guys have a great Father's Day if you're celebrating. And if you're not, I hope you guys can just chill on a day like today. Rest up so that you're ready and fresh for the following week. Peeps! That's Chronicles of a Plumber. Love you guys. Thanks again. And I'll see you guys very soon. Kenny Molotov, guys. Peace, baby.